Hello, I welcome you to Kenya Mathematics Classroom. On this particular episode, we are going to look at calculus. And calculus is of two parts. You will consider the differentiation, then you also consider the integration. Now, before we start with the differentiation, we will look at what we call limits. We try to find limits of constants, limit of polynomial functions, we have limit of rational functions, and we will look at limit of trigonometric functions. So, in general, let's look at what we call the limit. Now, we have limit of constants. We have limit of constants. Now, later in my presentation, I'll consider limit in general. But for now, we are looking at introduction of limit because we are going to apply this limit in the calculus. So now we have limit of constant. So if you have a constant, say k, when you are taking limit as x approaches a particular value of a constant, the answer is the constant. So if you have limit as x approaches 1 or 4, the answer is 4. If you have limit as s approaches 2 of 7, the answer is still 7. So if you have limit as s approaches any number of a constant, the answer is still the constant. So that is how we find limit of constant. That is how we find limit of constant. So if you also have limit as s approaches 2, then you have 14. The answer is still 14. Because whatever we have here is not in terms of x. And so it's still the constant. Then we have limit of polynomials. Limit of polynomials. Now with the polynomials, I have a presentation on the polynomials. So you can refer to my presentation or tutorials on polynomials so that you can understand polynomials in general. But for the sake of calculus, we are looking at the limit of polynomial functions. And a polynomial in x is any function that can be expressed as a naught x exponent n. You have a1 x exponent n minus 1. Then you have a2 exponent x exponent n minus 2. Then up to you have a n minus 1 x. Then you have a naught. You have a n. So your a naught, a1, a2, a n minus 1, and a n are all constant coefficients. Some of them may be 0. And the x is the variable, and the n is a definite positive integer. When you refer to my presentations on polynomials, you understand what we are talking about here. So, in general, this is how a polynomial function is expressed. So, if you are finding limit of polynomial functions, let's assume you have to find limit as s approaches a of a polynomial function. Let's say we have x squared plus 2x. This is a polynomial function and it's quadratic because the degree of the x is 2. When you refer to my presentations on polynomials, you understand what I mean by that. So when you are finding limit as s approaches the value a of the function, what you do is to substitute. Wherever you see x in the function, you substitute that by the value you have. So instead of s squared plus 2x, you are going to have a squared plus 2 times a. So this should be the answer. So that is how we find limit of polynomial functions. Wherever you see x or the variable, you substitute that by the number you are given. So its limit as s approaches a of x squared plus 2x. That means that wherever you see x in the polynomial function, you substitute that by the value of a. So example, if you have limit as s approaches 1 of, let's say, the same function, when you start the substitution, the limit is not seen again. So as s approaches 1 of the function x squared plus 2x, this should be 1 squared plus 2 times 1. And this should be equal to 1 squared is 1, 2 times 1 is 2, and 1 plus 2 gives you 3. So limit as s approaches 1 of x squared plus 2x is equal to 3. So that's how we find limit of polynomial functions. Let's say we have limit as s approaches 2. Then we have x squared minus 5x plus 6. This is also a polynomial function and it's quadratic because the degree of the x is 2. You can see that. So limit as f approaches 2 of this polynomial function will be x approaches 2. So it will be 2 squared minus 5 times 2. Then you have plus 6. And 2 squared will be 4 minus 10 plus 6. Don't forget that 4 minus 10 is minus 6. And minus 6 plus 6 will give us 0. So limit as s approaches the value 2 of the polynomial function x squared minus 5x plus 6 will give us 0. So that is how we find limit of polynomial functions. We only substitute the value of x that we are given into the polynomial function. Whatever you are getting is the answer. That is all. But take note that if the function, if whatever you are given is a constant, if it's a constant, then limit as x approaches any number of a constant is still the same constant. Take note. But if the function is in terms of x or any variable, then we do the substitution as can be seen here. So that is the difference between taking the limit of constants and limit of polynomials. In general, later in our study, we will consider a lot of examples on limit of polynomial functions so you understand it better. Then we also have what we call the limit of rational functions. And when we talk about rational functions, I also have a presentation on the same platform on rational functions, so you can also look at the presentation of rational functions so that you can understand rational functions in general. But for the sake of limit, we are going to consider one or two examples of rational functions. When we talk about rational functions is just the division of two polynomials. That is all. So when you divide one polynomial function by the other polynomial, whatever you are getting is what we call the rational function. So let's assume that we have the rational function f of x equals g of x over h of x. Don't forget that g of x is a polynomial function and h of x is also a polynomial function. So when you divide g of x by h of x, whatever you are getting is what we call the rational function. So rational functions is just the division of two polynomials, and that is what. Take note that the h of x must not be equal to 0. That is the denominator. The function here must not be equal to 0. If it is equal to 0, then it is no more a rational function. So take note of that. So g of x and h of x are all polynomial functions, and because we are dividing one by the other, we call it the rational function. So when you are taking limit of rational functions, let's look at how we take limit. If you have limit as x approaches a of the function f of x, don't forget that the function f of x is g of x over h of x. So when you are taking the limit, it will be limit as x approaches a of the numerator, that is g of x, all by limit as x approaches a of the denominator, that is h of x. So we take limit of the numerator, then we take limit of the denominator. That is what we are talking about. So that's the limit of rational functions. And when you are taking limit of the numerator, take note, it's limit as x approaches a of g of x. So the g of x is the polynomial function. So substituting a wherever you see x will now be g of a, or by the limit as x approaches a of h of x will also be h of a. It will be h of a. And so g of a over h of a will now be our answer. So that is how we find limits of rational functions. That's how we find limits of rational functions. Now take note that when the g of a divided by the h of a is giving you 0 and 0, if the g of a is giving you 0 and the h of a is also giving you 0, then that means that you are going to have 0 over 0. If it happens like that, you have to manipulate the function so that you can solve it. Later, I will show you what I am talking about here. So in general, that is how we find the limit of rational functions. So let's look at an example. Limit as s approaches 1, you have x squared plus 2x over x. Now we have limit as s approaches 1 of x squared plus 2x over x. So you can see this is a rational function because we have a polynomial x squared plus 2x up there. Then you also have a polynomial x down here. So because we are dividing one polynomial by the other, then we say that that is a rational function. So when you are taking limit of this rational function, we are saying that this is going to be limit as s approaches the value 1 of the numerator, that is x squared plus 2x, all divided by limit as s approaches the same 1 of the denominator. And now when you are taking limit as s approaches 1 of this function, that means wherever you see x, because the function is in terms of x, so wherever you see x in the polynomial function, you substitute that by 1. So instead of x squared plus 2x, we are going to have 1 squared plus 2 times 1, or by limit as s approaches 1 of x is also 1. And so 1 square is 1 plus 2 times 1 is 2. So 1 plus 2 is 3. Then 3 divided by 1 will give you 3. So take note that limit as s approaches 1 of x squared plus 2x all divided by x is equal to 3. Is equal to 3. Now let's take another example. Let's take another example. So we are now looking at limit of function. Limit of rational function. So example, let's assume that we are given limit as s approaches 3 of x squared minus 5x plus 6 all divided by 3. So now if you try to solve this, this will be all divided by x minus 3. Okay, let's take this example. So limit as s approaches 3 of x squared minus 5x plus 6 all by x minus 3. So you can see that this is a rational function because x squared minus 5x plus 6 is a polynomial function and x minus 3 is also a polynomial function. So because we are dividing one polynomial function by the other polynomial function, we call it a rational function. So if you want to find the limit of this, this will be limit, that is, we will take limit of the numerator. So taking limit of the numerator, we are going to have 3 square minus 5 times 3 plus 6. Then when we take limit of the denominator, we are going to have 3 minus 3 because x approaches 3. So we use the value 3. Now 3 square here will give us 9. 5 times 3 will give us 15 here. We have plus 6. All by 3 minus 3 will give us 0. 9 minus 15 is minus 6. And minus 6 plus 6 is 0. So we have 0 over 0. Now when you are getting this, it means you need to manipulate the function you are given so that you'll be able to solve it. Now, this is what I was talking about. So we are now, because we are getting 0 over 0, we want to do away with that. And so what we are going to do is, we are going to manipulate the question we are given. So we are given limit as s approaches 3 of x squared minus 5x plus 6 all by x minus 3. So take note that this can also be expressed as limit as s approaches 3. We can factorize this. When you refer to factorization on my platform, you understand what is really happening here. So when you factorize s squared minus 5x plus 6, we are going to have x minus 3. We are going to have x minus 2. Then all divided by x minus 3. So this can cancel this. And this will now be limit as s approaches 3. We are left with x minus 2. And so now limit as s approaches 3 of s minus 2. That's wherever we see x in the function, we substitute that by 3. So in doing that, we are going to have 3 minus 2. And this is giving us 1. So you see that we are getting the answer 1 from the same question. So when you are getting 0 over 0, then you need to manipulate the function. You need to manipulate the function so that you'll be able to solve for it. Then let's assume that we are also given an example. Limit as s approaches, let's say we have 3 here. Then we have x squared minus 9x. Then we have x squared minus 9. Then we have x minus 3. Let's assume that this is what we are given to solve. So limit as s approaches 3 of x squared minus 9 all by x minus 3. And this is also a rational function because you see that we are dividing one polynomial by the other polynomial. We are dividing one polynomial by the other polynomial. So it's a rational function. Now, when we are taking limit of this, when we take limit of the numerator, take note that it is x approaches 3. So this will be 3 squared minus 9 all by 3 minus 3. And 3 squared is 9. 9 minus 9 is 0. Over 3 minus 3 is 0. 0 over 0. So we need to manipulate this function so that we'll be able to solve it. Now, we have limit as s approaches 3 of x squared minus 9 all by x minus 3. Take note that this is the same as you have limit as s approaches 3. This is difference of 2 squares. So s squared minus 9 is the same as s squared minus 3 squared because 3 squared is 9. So we have s squared minus 3 squared all by x minus 3. And this can further be expressed as limit as s approaches 3. S squared minus 3 squared, difference of 2 squared. This can be expressed as s plus 3 times s minus 3. Don't forget it's all by s minus 3. So this can cancel this. And we are left with limit as s approaches 3 of the function left there is s plus 3. So if you have limit as s approaches 3 of the function s plus 3, that means that wherever we see x in the polynomial function, we substitute that by 3. And so in doing that, f plus 3 will now be 3 plus 3, and the answer is 6. So do you see that we are getting 6? It is not 0 over 0. So when you are getting this, when you are taking limit of rational functions and you are getting this, you need to manipulate the function so that you'll be able to solve. And that is what I was talking about. So this is what we call the limit of rational functions. This is what we call the limit of rational functions. So the answer is 6. Now we are going to look at the limit of some simple trigonometric functions. Trigonometric functions. And this is just the introduction. These are just the introduction. Later I will consider limit in general and you understand it better. But for the sake of calculus, these are the little things I want you to understand. So we will look at some trigonometric functions. And take note of this. If you have limit as s approaches 0 of sine x, the answer is 0. And if you have limit as s approaches 0 of cos x, the answer is 1. If you have limit as s approaches 0 of sine x over x, this is equal to 1. Later, I will prove all these things. But for the sake of calculus, we are only looking at the introduction. So these are simple trick functions you need to know. That when you are taking limit as s approaches 0 of sine x, this will give you 0. Then limit as s approaches 0 of cos x is 1. Then limit as s approaches 0 of sine x over x is equal to 1. Take note, this is sine of a function over the same function. Now, let's look at this example. Let's assume that we are asked to find limit as s approaches 0 of sine 3x over x. Now, take note that this will not be equal to 1 because we have sine of 3x over x. The function here is different from the function we have here. So with this, you need to also manipulate so that you'll be able to solve. Take note that we are looking at limit of trigonometric functions. So with that question, we're given limit as s approaches 0. We have sine 3x over x. If the function we have here, that is 3x, is the same function here, then it means it's equal to 1 because limit as s approaches 0 of sine x over the same function x is equal to 1. So what we do is we try to multiply the numerator by 3, then we also multiply the denominator by 3. And take note that whatever we do to the numerator, if you do the same thing to the denominator, we have not changed the question because when 3 cancels 3, we are back to the same answer again. Now this can be expressed as we can have 3 before the limit. So we have 3 times limit as s approaches 0. Then we are left with only sine 3x here, all divided by 3x. So do you see that now our function 3x here is the same 3x here? And you know that the whole of this, according to the number 3, limit as s approaches 0 of sine of a function over the same function is equal to 1. That means that this should be 3 times. The whole of this is 1 because limit as s approaches 0 of sine 3x over the same function is equal to 1. So 3 times 1, this will now give us 3. So in general, this is what we call limit. This is what we call limit of constants, limit of polynomial functions, limit of rational functions, and limit of these simple trig functions. But that will be all for now on this particular episode. Thank you.